Hi everyone, we meet again in this class. So in last time example that I gave you previously, I have shown you two examples in our daily life. One is your water dispenser and another one is the water heater. So in this video I'm going to proceed on how can we make use of this knowledge that we gain in open system and steady flow energy equations in solving our daily life. Hence, the learning objective for today is, at the end of this video, students should be able So, once you have read the objective, let's have a look at this video that we have here. The moment we press this button, the water dispenser will flow out from the system. The hot or cold water flowing out, hence we got the outlet flow. And the water inside this area is considered as inlet flow. So now, this water dispenser, we can treat it as an open system. So, can it be analyzed using the steady flow energy equations? We need to come up with a diagram first that resemble the open system of this water dispenser, where you have flow coming in and flow going out of the water dispenser, and also you have some thermodynamics property to find out. Hence, this can be treated as throttle valve in your lecture notes. Remember that we have 5 types of steady flow energy devices. Therefore, we can make use of these steady flow energy equations, and with the help of this assumption for throttle device, so we can solve for this problem of open system. Now let's have a closer look at the steady flow energy equations that we have here, right? Since this throttle valve is not doing any work, okay, therefore we can cancel out the work term over here. And we also can cancel out the term of kinetic energy, since if we treated this flow very minimal slow, which is it's not going to be any significance due to the flow. And also we can cancel out this datum because it doesn't have any significance as well like the kinetic energy. Hence, this will leave you with Q net, right? We cannot say for sure that this is an adiabatic process because we did not insulate this area here. Unless for some problem, if they insulate this pipe area, then we can have a adiabatic process. But since this area is not being fully covered, okay, or insulated, so this will be some heat loss here, whether it is heat gain or heat loss. That's why we need to figure out by using the steady flow energy equation. So from the deductions of the term here, we finally have this form, which is Q net is equal to m dot H2 minus H1. Therefore, we will need to figure out what is the value of H1 or enthalpy at state 1, enthalpy at state 2 where the flow is going out, and what about the mass of this flow, and as well as the Q net. Alright, usually the form of questions that we have as our homework or in class or in test or in final exam, some of this term is already given to you. But when you go for a real encounter, real problem to be solved, all this value, apart from you make use of the steady flow energy equations to get to solve the problem, you need also to find out a certain property by using certain tools. For example, as you can see here, the m dot, right? How are you going to get the mass flow rate? Okay, first you will need to time the seconds. And how are you going to do that exactly? You will need a cup, a glass or a cup to dispense the water, right? And you need to time how many times does it takes to fill up the water inside the cup, right? And then you need to calculate the volume of the cup and convert it into liter. And next you need to convert that liter so that you will get the mass. Next is, how are you going to find out your state 1 here, right? From the previous class, when we learned about reading your property table, you need to know 2 known value. But in this case, in order for you to get the enthalpy at state 1, you will need to have at least the value for pressure and temperature. If it's in homework or test or final exam, this is usually been given to you. But since this is a daily problem that you probably as an engineer are going to encounter and to solve, it is actually you need another measurement tools, right, to be able to measure the temperature and pressure inside this area. Perhaps at this stage we can make use of pressure and temperature sensor so that we can tap how much is the pressure and temperature inside this water dispenser. Next is to find the state 2 condition, right? Let's have a look at the state 2 condition over here. As you can see, the water is flowing out to the environment of the room that you are in. Okay, so given that environment, the pressure should be as 1 atm, the same with the environment, and temperature too you can get from what is the temperature of the room at that moment. Okay, and you also can get the H2 to be HF because the fluid flowing out here is still in a liquid form. It is not in saturated gas. Probably a hot water, you will need to find the X quality of X if needed. If not, this can be assumed as HF. So what can we conclude from this video is we look back at the learning objective where we have to be able to analyze our daily life activity and framing it as thermodynamic open system as what we have did here, right? You frame this water dispenser as a throttle valve, and this is actually an open system. And next, we have to be able to apply the SFEE or steady flow energy equation to solve the problem, where we make use of this knowledge and we simplified it into this term. We have to apply appropriate measuring tools to obtain the unknown but observable thermodynamics property. So this is what it is meant where you need a measuring tool like pressure and temperature sensor to measure the things inside this water dispenser. Not the things, the properties, sorry. And finally, we should be able to solve the problem of simplified steady flow energy equation using the property table. So because this is water property, so we can make use of table A4, A5 and A6. Then we can solve for this one, and finally you will obtain this Q net, right? So if you get the negative value for this Q net, it indicates that this flowing water is rejecting heat. Okay, it's reject heat. So it goes the same with the second law, where We will continue second law in our next lecture. But before I leave you, right, let's have a look at this water heater. Can this be the same as the problem that we discussed earlier? Till then, I left you for you to try out on your own. Thank you.